Alright, so today we're doing an introduction on scatter plots. Some vocabulary that we want to start off with. You'll hear lots of different words that apply to the same thing. We've got association, correlation, relationship, and the word trend. Okay? Any of these words, positive association, positive correlation, positive relationship, positive trend. It's positive if both the variables are increasing together. So for example, miles per hour is a positive association because the more miles I drive, the more hours I drive, the more miles I drive. They're both increasing together. Okay? A negative association would be where one is increasing but the other is decreasing. So for example, let's say the more I download onto my phone, the less memory I have. Right? It's a negative association. As the downloads increase, the amount of space you have left on your phone decreases. So that's a negative association. So this one would be increasing. Let me write this. This would be increasing while your memory is decreasing. Okay? Here, miles per hour, it's increasing, the hours are increasing, and the miles that you travel are increasing. Okay? And then you've got no association. There's no correlation at all between the two variables. So an example might be your test scores and the number of siblings you have. There's no correlation to this. Your test scores don't increase with the number of siblings that you have, nor do they decrease depending on how many siblings you have. So this would be no association. This would be your example. Okay, so these are examples of each. On the graph, what they look like, if it's positive, generally all of the data, it's not necessarily linear. I can't connect them all and form a straight line, but in general, the data is going up the graph, just like slope guy, right? Here, in general, the data is going down the graph from left to right. That's negative. And here, there's no association. They're just all over the place, right? So let's look at these examples and see if we can identify whether or not it's a positive, negative, or no association. So the number of hours that a person has driven and the number of miles driven. I think I just did this one. So as the number of hours increases, the number of miles increases. So if they're both increasing, this is a positive correlation. Okay. Number 2. Oh, I swear I did not read these before I gave you the examples. As the number of siblings increases, a student has, the number of siblings a student has and the grade they have in math class, that is no correlation. You can tell that we've used these examples a lot in the past. That's why they were on top of my brain. Alright, so the age of a car and the value of the car. So as the age of the car increases, what happens to how much your car is worth? The value of your car actually decreases. So one's increasing while the other's decreasing. That is a negative correlation. The older your car is, the less it's worth. Okay? Number 4, the number of weeks a DVD has been out and the total sales. So the number of weeks, as the number of weeks increases, what's going to happen to the sales? Your sales are also going to increase because the longer it's out, the more you sell. So that would be a positive correlation. So these are your answers to 1 through 4. This one was positive, no correlation, negative, and positive. Okay. Number 5, what can be concluded from the scatter plot? So it looks like I'm comparing average age to the minutes of TV watching. So it looks like as you get older, what's happening to the amount of TV that you watch? You watch less and less TV is what it's looking like. Yeah, this is the minutes of TV watching. Alright, so let's look. The older a person gets, the less television he or she watches. So, as we get older, in general, the amount of TV that we're watching is coming down. That is true. Because in general, we are going down the graph. Okay, number 6, there's no relationship between the age and television watching. That's false. We can definitely see a trend here. The data is definitely going down the graph. So that's false. The older a person gets, the more television he or she watches. That is false. We just said the older they get, the less they watch. Number 8, as a person gets older, their taste in television shows change. Can we conclude that? Can we tell what they're watching? We can't tell what they're watching. We can only tell how many minutes they're watching. So we cannot determine the taste of their television shows. We can only determine their minutes. Okay? All right, continuing on. This says the data below represent time and distances for car trips. So use the data to answer parts A, B, and C. Part A is done for you. Okay, so they made the scatter plot for us. And as you can see, hours are along the bottom, and the distance is along the y-axis. So they went over 5 units and up to 250 miles. They went over 10 and up to 200. They went over to the 5 and 250 is right there. 3 and 140 is right here. So they've plotted all the points for you. And they've labeled the axes. Alright, so describe the association between time and distance. So in general, I know that this guy here is kind of messing things up. But in general, our data is going up the graph. So the association would be a positive association. I don't care about it being perfect. You can come on in. Describe any outliers. This guy right here, because he's kind of set apart from the rest of the data, he would be an outlier, because he's lying outside the rest of the data. So our outlier is at 10 hours, and they traveled 200 miles. That would be at point 10, 200. I'm almost done. Last one. Number 10, the data below represents the number of registers at grocery stores and the number of minutes shoppers wait until scanning the groceries. All right, so we've got our minutes along the bottom, number of registers here. So 10 registers takes 3 minutes. Number of registers at grocery stores and the number of minutes shoppers wait. Okay, so when there's 10 registers open, it'll take 3 minutes to check out. If there's 5 registers open, it's going to take longer, 7 minutes. All right, it says make a scatter plot. So we've got number of registers along the bottom. So for 10 registers, we've got 3 minutes. 5 registers, we've got 7 minutes. I'm going to go up to here. 12 registers, we've got 2 minutes. 8 registers, 4. 4 registers, 1 minute. And 6 registers, 6 minutes. Describe the association. In general, the more registers you have, the less time it takes to check out. Makes sense. The data is going down the graph, so that is a negative association. We do have this outlier. He's set apart from the rest of the graph, the rest of the data. So our outlier is at 4 registers. It takes 1 minute. That point would be at 4, 1. And that is it.